Good morning everybody. In previous class we study about the first topic, solid state. In solid state we study about the general characteristics of solids and the characteristics of solids, that is a crystalline and amorphous. We study the difference between the crystalline and amorphous solid and the classification of crystalline solids of ionic crystals, covalent crystals, etc. Next we study about the primitive and non-primitive with examples, and 7 primitive crystal systems, that's a basic system, 7 crystal primitive systems, and primitive and non-primitive containing, that is a Bravais lattice, 14 Bravais lattice. Okay, next we are going to see the simple cubic unit cell, that is the number of atoms in a cubic unit cells. Okay, there are in our textbook they are given 3 simple unit cells, that is a face centered, body centered, and a simple cubic. Okay, first we see the simple cubic unit cell. In simple cubic unit cells, first taken a unit cell, that is a cubic unit cell. In simple cubic, the atoms must be present only in a corner position. Okay, there is no any other position atoms are occupied, only the corner position the atoms are occupied. Here there is 8 corners in a simple cubic. Okay, in each corner is occupied by 1 atom, and each atom is shared by 8 unit cells. So let us take one example. This atom is shared by 8 unit cells, that is, it is simply represented as 1 divided by 8. Here 1 means it indicates the atom, 1 atom, divided by 8 means sharing of unit cells. Okay, in this manner each corner is shared by 8 unit cells, 1 divided by 8, 1 divided by 8, 1 divided by 8. Okay, here simply taken a example. Here note that it is a crystal system. For example, we taken only 1 atom in a cubic cell. Here this 1 atom is shared by 8 unit cells, 1, 2, 3, 4, that is 4 unit cells are at the top position, and 5, 6, 7, 8 remaining 4 unit cells are in a bottom. Totally this 1 atom is occupied by 4 plus 4, 8 unit cells. Okay, in this manner the remaining each corner of the atom is shared by 8 unit cells, that is example this atom is shared by 8 unit cells, so 1 divided by 8. Again it is a 8 unit cell, that's 1 atom, that is 1 atom is shared by 8 unit cells, again it's 1 divided by 8. In this manner we could taken only 1 unit cell, and that 1 unit cell is taken for an example. The number of atom in a simple cubic unit cell, for here calculating the number of atom per unit cell. Okay, here calculation is based upon the number of atom per unit cell. It's a very important, per unit cell. Per unit cell means that is a for single unit cell. Here then the calculation, the number of atoms at the simple unit cell is a number of atoms at the corner divided by 8. Here number of atoms means that is totally 8 atoms. That is because there is 8 corners, each corner is occupied by 1 atom, so the number of atoms means 8 atoms. So 8 atoms, this is the atoms, and this each atom is shared by 8 unit cell, so it is a unit cell, neighboring unit cell. In this manner 8 divided by 8 is equal to 1. If we taken in the, we can calculate in this format also, 1 divided by 8, okay, plus 1 divided by 8 plus 1 divided by 8, 1 divided by 8, 1 divided by 8, 1 divided by 8 plus 1 divided by 8, 1, 2, 3, 4, 5, 6, 7, 1 divided by 8. So 8 divided by 8 is cancelled is equal to 1. Okay, we can simply calculate in this manner also. So the number of atom per unit cell is very important ones. Per means one unit cell is only one. But when we saw there is a 8 atoms. When we simply saw the unit cell, there is 8 atom, but the only one atom belong to the one unit cells. Okay. Next one is a body centered cubic. In body centered cubic, there is a 8 atoms at a corner. One atom is present in the center of the unit cell. Okay, that is the body center. The calculation is similar to the simple unit cells. So number of atoms in a body centered cubic is NC divided by 8. NC means number of atoms at in a corner. NB means in body center. I also explained that each atom or in a corner is shared by 8 unit cells. Okay, so 8 divided by 8 we already know, calculate in a simple cubic unit cell. And for body centered atom is shared by only one unit cell. Okay, this body centered atom is not shared by any other neighboring unit cell. So this body center atom is shared by only belong to this unit cell only, not shared by any other neighboring unit cell. Okay, so the number of atom is 1. Number of atom is 1. The number of unit cell, that is a shared unit cell, SHARED, shared unit cell is also 1. Okay, so 1 divided by 1. Here also know that 8 divided by 8. So cancel, we get 2. So the number of atoms belong to the body centered cubic, that's a per unit cell, is 2. Okay. Next one is a face centered cubic unit cell, FCC. Here also in the face centered cubic there is a 8 atoms are in a corner position, and for a cube there is a 6 faces. For a cube there is a 6 faces. For a cube, let us take in this cube. This is 8 corners, 1, 2, 3, 4, 5, 6, 7, 8, and 6 faces. 1, 2, 3, 4, 5, 6. That is a 6 faces. Top, bottom, front, back. 4 faces, then side faces. 5, 6. So totally 6 faces of each unit cells. Okay. In the case of face centered cubic unit cell, there is a 6 faces, and each faces at a central position there is occupying atom. Okay, that's a 6 atoms. 1, 2, 3, 4. One is a front one, another one is a back one. 6, 5, 6. Okay, 6 faces. Each faces carrying 1 atoms. Okay, these face centered atoms is shared by this atom shared with 2 unit cells. Okay, we already know that the corner atom is shared by neighboring unit cell is a 1 divided by 8. That is a 8 unit cell is sharing corner atom, and 1 unit cell is sharing body centered atom. Here in the case of face centered, each face centered atom is shared by 2 unit cells. Okay, that unit cell, let us take that is a cube. In this cube, that is the atom in a face. Okay, it is a face centered atom. This face centered atom is attached with there is another cube. That cube, here this atom is touching with the neighboring face. Okay, so that 2 unit cell is sharing the face centered atom. Okay, this face centered atom is sharing with this 2 unit cell. This face centered atom not touch with the another any unit cells. Only this these 2 faces, this unit cell faces and this unit cell faces that touches the face centered atom. So each face centered atom is shared by 2 unit cells. Okay, so NF divided by 2, that is the number of atoms in a face is 6. Okay, is the number of atoms, and it is sharing unit cells is 2. So 6 divided by 2, cancel, we get 3. Here also already we know that 8 divided by 8 for corner atom is 1. 1 plus 3 is a 4. 4 is the number of atoms, that is the per unit cell of face centered cubic. Number of atom per unit cell. Okay. Next one is the calculation involving the unit cell dimension. Whether the crystal system is a simple cubic or body centered or face centered is determined by the formula n lambda, that is a Bragg formula. N lambda is equal to 2d sin theta. Lambda is the wavelength, theta is the angle of diffraction. From this formula we can also calculate the interplanar distance, that is the distance between the two planes of the crystal system. That is based upon this formula, that d is equal to n lambda divided by 2 sin theta. In this way we could calculate the interplanar distance also. Okay, that's all. It is a Bragg equation. Next one, calculate the density of the crystal system. The density is denoted by a symbol rho of a unit cell is a mass of the unit cell and the divided by the volume of the unit cell. First we taken as a mass of the unit cell. That mass of the each unit cell is depend upon the unit cell containing atoms. The atoms on a corner, definitely the atoms must be 8 atoms must be in a corner, and the remaining atoms may be present in a face centered or body centered. First, the total number of atoms to the unit cell, that is n. The mass of the unit cell is depend upon the total number of atom to the unit cell n, and next one is the mass of only one atom, mass of the one atom, that is denoted by symbol m, small m. So mass of the total unit cell is multiplication of total number of atoms to the unit cell and mass of one atom. So total number of atom into small m, and mass of one atom is determined by molar mass of the atom divided by Avogadro number. So molar mass divided by Avogadro number. Let us see with the example. Molar mass of carbon. Here 12 gram of carbon having 6.023 into 10 to the power of 23 atoms. We know that 12 gram of carbon, if we take 12 gram of carbon, the number of atoms is 6.023 into 10 to the power 23. But we know the weight of only single atom, only one atom. So come to the 6.023 in the denominator. So 12 divided by 6.023 into 10 to the power 23. When we cancelling, we get 2 into 10 to the power minus 2 is the mass of only one carbon atom. Okay, this much of 23 atoms weight is 12 gram. Then one atom weight is 2 into 10 to the power minus 23 grams. That's all, grams. Okay, that is the mass of one atom. So we can calculate the mass of only one atom. For mass of one atom is calculated by molar mass divided by Avogadro number based upon this formula. Okay, next one, see, when we substitute this, that is a n is the total number of atoms into, for small m we can substitute m, molar mass divided by Avogadro number. So mass of the unit cell is n, number of atoms at the unit cell n, and next one is the molar mass capital M and Avogadro number Na. Okay, when we substitute this n into m divided by Na in the molar mass unit cell, n into m divided by Na divided by volume of the unit cell. We know that the volume, the unit cell is a cubic, the volume of the cube is a cube. Okay, length into breadth into height. So each length, breadth, with all are the same value, so that is a cube. When we calculating the density based upon this formula. Okay.